press the bell icon on the YouTube app and never miss another update.
Hello students, welcome back to the video classes. Today let us move on to part 51 of some basic principles and techniques. So here in the previous class we discussed about inductive effect, types of inductive effect, positive inductive effect and the negative inductive effect. Positive inductive effect is also called electron releasing inductive effect, and negative inductive effect is also called the electron withdrawing inductive effect. And in the previous class we discussed about some importance of the applications of inductive effect, where this inductive effect is useful in explaining the organic reaction mechanisms and what is its importance in the properties of organic compounds, and also, or you can say, what are the applications of inductive effect. So in the previous class we discussed about the stability of free radical, stability of carbocation and the high reactivity of haloalkanes compared to that of alkenes. Today let us move on to the next application of this inductive effect, that is nothing but stability of carbon ion. Stability of carbon ion. So what do you mean by carbon ion? Carbon carrying, the chemical species where the carbon carrying negative charge is nothing but carbon ion. Correct? Now there are three types of carbon ions, that are primary, secondary and tertiary. If the negative charge is on the primary carbon, then it is called primary carbon ion. If negative charge is on the secondary carbon, then it is called secondary carbon ion. If a negative charge is on the tertiary carbon, then it is called tertiary carbon ion. Now let me consider what is the order of stability of this carbon ion among primary, secondary and tertiary. So which is more stable? Then as I said in the previous class, what do you mean by stability of carbon ion? So to get the stability, diminishing of the negative charge, the diminishing of the negative charge which is present on a carbon atom gives the stability to carbon ion. So stability of carbon ion means diminishing of the negative charge. To diminish the negative charge, electrons should be removed from the negatively charged carbon, which means to say any atom or a group of atom which is electron withdrawing, if it is attached to the carbon, then negatively charged carbon, then the diminishing of the negative charge takes place and the stability increases. Whereas any electron releasing group is attached to the negatively charged carbon, further negative charge increases, means electron rich center on the carbon further increases, then the stability decreases. Then the electron withdrawing group stabilizes the carbon ion, whereas electron releasing group destabilizes the carbon ion or decreases the stability of the carbon ion. Which means to say, let me consider the tertiary carbocation here. CH3, 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 and here is a negative charge. This is called tertiary butyl carbon ion. Tertiary butyl carbon ion. In this case, the negative charge is on the tertiary carbon, correct? Now what are the groups attached to negatively charged carbon? Methyl groups. How many methyl groups are there? 3 methyl groups are there. What is the nature of methyl group? It is electron releasing, means it displaces the sigma electron towards the carbon. So because there is a bond between two carbon atoms, but methyl group is less electronegative than this carbon, therefore the displacement of the sigma electron takes place towards negatively charged carbon, thereby methyl group exerts positive inductive effect. It exerts positive inductive effect. Similarly, one more methyl group is there. This also exerts positive inductive effect because methyl group is an electron releasing group. It is an electron releasing group. Similarly, another methyl group is there that also exerts positive inductive effect. So here one methyl group is, if it is present, it releases the electron, thereby increases the negative charge. When there is an increase in the negative charge, stability decreases, correct? And this exerts positive inductive effect. When the number of methyl groups goes on increases, magnitude of positive inductive effect increases, and there is an increase in the negative charge on the carbon, stability goes on decreases. Then you can take the conclusion, it is inversely proportional to positive inductive effect. So, higher the positive inductive effect or the electron releasing inductive effect, lesser is the stability of the carbon ion. Similarly, let me consider the negatively charged carbon if it is attached to, here it is fluorine. So, one of the hydrogen atoms of methyl group, if it is replaced by fluorine, as you know that fluorine is more electronegative than this carbon and also than this carbon. Therefore, it withdraws the electron from the sigma bond, carbon to fluorine sigma bond. The displacement of the sigma electron takes place towards fluorine, and thereby fluorine exerts negative inductive effect. But CH2 group exerts positive inductive effect here. But as fluorine is more electronegative than CH2, the negative inductive effect predominates over positive inductive effect. The negative inductive effect predominates over positive inductive effect. So, overall effect here is negative inductive effect on the negatively charged carbon. So, overall effect, what is the overall effect? Negative inductive effect exerted by the fluorine is more on the negatively charged carbon. So, negative inductive effect means electron withdrawing inductive effect. Electron withdrawing inductive effect. It withdraws the electron from the negatively charged carbon. Thereby, diminishing of the negative charge takes place. Decrease in the negative charge, and thus the stability of the carbon ion increases. Which means to say, negative inductive effect increases the stability of the carbon ion. Therefore, it is directly proportional to negative inductive effect. Higher the magnitude of negative inductive effect, higher is the stability of the carbon ion. Now, on the basis of that, let me give what is the decreasing order of stability of the carbon ion. So, let me give the examples here. So, take an example of first one. The order of stability of, that is decreasing order of stability of different carbon ions. What is the decreasing order? So, let me give primary carbon ion here, CH2 minus. This is ethyl carbon ion, correct? Ethyl carbon ion is primary. Then CH3, CH3, that is isopropyl carbon ion. This is secondary. Why it is secondary? Because negative charge is on the secondary carbon. This carbon is secondary because it is bonded to two different carbon atoms, two carbon atoms. Now, tertiary, that is CH3, and a negative charge. This is tertiary butyl carbon ion. Tertiary butyl carbon ion. So now here this exerts positive inductive effect. One positive inductive effect exerted by one methyl group, and here the two methyl groups are there. These exerts positive inductive effect. The positive inductive effect is exerted by two methyl groups, and here the positive inductive effect is exerted by three methyl groups. So these exerts positive inductive effect as the methyl group is electron releasing. So here the magnitude of plus psi effect is less, and here it is more, and here it is still more. Therefore, and stability is inversely proportional to positive inductive effect. So primary carbon ion is more stable than secondary, which is more stable than tertiary. Then what is the order? Primary carbon ion and secondary carbon ion and tertiary carbon ion. So this is the order of the stability of the different carbon ion: primary, secondary, tertiary. That is P, S, T. Primary, secondary, tertiary. So this is the order of stability of carbon ion. Now let me give in primary. That is, this is primary ethyl carbon ion. This is primary propyl carbon ion. This is primary butyl carbon ion. See here, methyl group, ethyl group and propyl group. As you know that positive inductive effect from methyl to propyl group goes on increases. Positive inductive effect increases with increase in the number of carbon atoms in a primary alkyl group. So all the three are primary here because it is attached to only one carbon, C2H5, CH3, CH2, CH2. Here CH3, CH2, CH2. So which means to say it is bonded to only one carbon. All these are primary. Among the primary carbon ion, as the size of the alkyl group goes on increases, which means to say as the number of carbon atoms in a primary alkyl group increases, magnitude of positive inductive effect increases. So from here to here, magnitude of plus sign effect increases. Therefore, stability, in other words, stability decreases. Stability decreases. Magnitude of positive inductive effect from methyl to propyl group increases. Stability decreases. So you have to note down this. Among the primary carbon ion, as the size of the alkyl group increases, magnitude of positive inductive effect increases, stability decreases. So ethyl carbon ion is more stable than propyl carbon ion. 2 plus 1, 3 carbon atoms total. Propyl carbon ion, which is more stable compared to that of butyl carbon ion because of increase in the magnitude of positive inductive effect. So as the magnitude of positive inductive effect increases, stability decreases. So let me give one more example here. So this is the general order of decreasing order of stability. You have to remember this, and this is important for your board exams. Let me give few more points which is useful for your competitive part. So let me give one more example here. Consider CH3, CH2, CHF, CH2 minus CH3, CHF, CH2, CH2 minus CH3, that is CH2F, CH2, CH2, CH2 minus. So in the beginning that we have propyl group is attached to the negatively charged carbon, correct? Propyl group. But in propyl group, one of the hydrogen atoms is replaced by fluorine, and propyl group exerts positive inductive effect, no doubt, and fluorine exerts negative inductive effect, correct? So propyl group in general exerts positive inductive effect because it is electron relative. Fluorine exerts negative inductive effect. So since it exerts negative inductive effect, then you can say this is more stable compared to that of, this is N-propyl, that is butyl carbon ion. So can you say this? This is more stable compared to that of this. The reason is that, so one hydrogen atom is attached, replaced by the fluorine, which exerts negative inductive effect. When it exerts negative inductive effect, magnitude of positive inductive effect given by this group, what is this group? C3H7, propyl group, decreases. So due to the presence of fluorine, which exerts negative inductive effect, the magnitude of positive inductive effect exerted by the propyl group decreases. When the magnitude of plus I effect decreases, stability increases. Therefore, this is fluorine attached propyl, that is N-butyl carbanion, 1, 2, 3, 4. Butyl carbanion is more compared to that of butyl carbanion. Fluorine substituted, that is 2-fluoro-butyl carbanion it is. 1, 2. 2-fluoro-butyl carbanion. But this is butyl carbanion. Substitution is fluorine, which exerts negative inductive effect. So now the same fluorine is replaced in the next carbon here. Next carbon, 3-fluoro. This is 4-fluoro. So 1, 2, 3, 4. 1, 2, 3. This is 1, 2. 2-fluoro. This is 3-fluoro. This is 4-fluoro. Which means to say the distance between the atom with the negative inductive effect and the source of inductive effect, negative charge is here, it increases. So this is the source and this increases from here to here. As the distance increases, magnitude of negative inductive effect given by the fluorine also decreases. Then what we can say, from here to here, just you note down this and later on you take this, from here to here, what happens? Magnitude of minus I effect decreases, therefore stability decreases. Stability decreases. Magnitude of minus I effect decreases, therefore stability decreases. And one more example, you take CH triple bond C minus, CH2 double bond CH minus, CH3 CH2 minus. As we know that sp hybridized, sp2 hybridized, sp3 hybridized. From here to here, percentage of S character, what happens? Decreases. Electronegativity of carbon decreases. So negative inductive effect decreases. Therefore, the stability decreases. Stability decreases. Reverse order. Here, this is sp hybridized carbon, more electronegative carbon, therefore it withdraws the electron. Compared to that of the sp2 hybridized carbon, because it is less electronegative, its percentage of S character is 33.33%. And if we move on to CH3 group, it is almost electron releasing. The electronegativity of carbon atom of a methyl group is very less, as the S character is 25%. So therefore, its electron withdrawing capacity is very less, rather electron releasing capacity is more. Therefore, increases the positive inductive effect, and the negative inductive effect, as it less, magnitude is less, definitely the stability decreases. Lesser the magnitude of minus I effect, lesser is the stability, because it is directly proportional. These two are examples for your competitive exam. So this is one more application of inductive effect. The stability of carbon ion can be studied under the inductive effect. Okay, now let us move on to the next application. Fifth one. So fifth one, acidic strength of carboxylic acids. acidic strength of carboxylic acids. So carboxylic acid, RC double bond OH. This is carboxylic acid. COOH group is the functional group of carboxylic acids. Correct? Why this is called acid? Because it is a proton donor. How it acts as a proton donor? Because of this bond. OH bond is polar. Since here is a sigma bond between oxygen and hydrogen, oxygen is more electronegative. Therefore, it withdraws the bonded pair of electron, or the displacement of the sigma electron between oxygen and hydrogen takes place towards the oxygen. Therefore, here is a carbon. This gets the negative charge and it possesses a partial positive charge. Then the OH bond becomes polar here. The bond becomes polar because there is a charge separation between oxygen and the hydrogen. Since it is more electronegative, it acquires a partial negative charge. Hydrogen atom acquires a partial positive charge. Then this OH bond undergoes heterolytic cleavage and it releases proton. So it releases proton. H plus is nothing but proton. So since it donates proton, it acts as an acid. So proton donor is nothing but an acid. But the acidic strength of this carboxylic acid depends on tendency to release the proton. So when the tendency to release the proton is more, then the acidic strength is also increases. So acidic strength of carboxylic acid depends on which factor? Tendency to release the proton. ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ ಬೇಗ ಪ್ರೋಟಾನ್ ನ ರಿಲೀಸ್ ಮಾಡುತ್ತೋ ಅದು ಮೋರ್ ಅಸಿಡಿಕ್ ಅಂತ ಕರಿತೀವಿ. ಟೆಂಡೆನ್ಸಿ, it shows a greater tendency to release the proton, then that molecule is more acidic, then that acid is more acidic. So acidic strength depends on which factor? That depends on tendency to release proton. So when the tendency to release proton increases, acidic strength also increases. That depends on what? So this is the functional group and this is the bond and it has to release proton from this bond. So the tendency to release proton depends on strength of this OH bond. Strength of the OH bond. When the OH bond is weak, then cleavage becomes easier and the proton release is more. Thereby it increases a tendency to release the proton, acidic strength increases. If the OH bond is strong, then cleavage or the breaking of the bond becomes difficult and the release of proton is difficult and the acidic strength decreases. So very simple, acidic strength of carboxylic acids depends on tendency to release a proton. Tendency to release proton depends on the strength of the OH bond. When the OH bond is weak, cleavage of the bond becomes easier, proton releasing is easier and the acidic strength increases. When the OH bond is strong, a bond is strong ಆಯಿತು ಅಂದರೆ cleavage of the bond becomes difficult and tendency to release the proton decreases. Then what happens? Tendency to release the proton, if it decreases, acidic strength also decreases. So the strength of the OH bond depends on the group attached to the carboxylic acid. ಯಾವ group ಇಲ್ಲಿ attach ಆಗಿರುತ್ತೆ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. For example, if the group is electron withdrawing, if it withdraws or displaces the sigma electron of this carbon towards itself, this is a substituent group, then it exerts negative inductive effect. Correct? It exerts negative inductive effect because it is electron withdrawing group. Electron withdrawing group. Correct? So if a group is electron withdrawing group, then the displacement of the sigma electron takes place towards this group. Thereby this group exerts negative inductive effect. So this displaces the bonded pair of electron. Simultaneously this also displaces the sigma electron towards this, because as we know that negative inductive effect takes place along the carbon chain up to 3 carbon atoms, Therefore, displacement of this sigma electron also takes place towards the group. Thereby, the OH bond becomes weak. The OH bond becomes weak. Cleavage of the bond becomes easier. Proton releasing tendency is more. When the proton releasing tendency is more, then the acidic strength increases. So, the group with minus I effect, negative inductive effect, or any electron withdrawing group, or any group which is more electronegative than carbon, if it is attached to the COOH group, then the OH bond becomes weak and the cleavage of the bond becomes easier. Proton releasing tendency is more and thereby acidic strength increases. Whereas if the same group, if it is attached to the carboxylic acid and this group is electron releasing group, then it exerts positive inductive effect. It gives this electron, it displaces the sigma electron to the carbon and thereby it displaces this sigma electron towards the oxygen. So here oxygen is more electronegative. When the electron density is less on the oxygen, again it withdraws the electron from this bond and thereby the bond becomes weak here. But here when the displacement of the sigma electron takes place towards the carbon or it is away from the substituent group, then you can say it is electron releasing group. It increases the electron density on the oxygen also. When the electron density on the oxygen increases, it does not withdraw the electron of this bond towards itself. Thereby, the OH bond becomes strong. OH bond becomes strong. ಯಾವಾಗ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಸೆಪರೇಷನ್ ಆಗಲ್ಲ ಆಗ ಬಾಂಡ್ ಏನಿರುತ್ತೆ ಸ್ಟ್ರಾಂಗ್ ಇರುತ್ತೆ. ಯಾವಾಗ ಚಾರ್ಜ್ ಸೆಪರೇಷನ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಯಾವಾಗ ಆಕ್ಸಿಜನ್ ಬಾಂಡೆಡ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಕಡೆಗೆ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ ಆಗ ಚಾರ್ಜ್ ಸೆಪರೇಷನ್ ಆಗುತ್ತೆ. ನೇಚರ್ ಆಫ್ ದ ಬಾಂಡ್ ಬಿಕಮ್ಸ್ ಪೋಲಾರ್. ಆಗ ಬಾಂಡ್ ಏನಾಗುತ್ತೆ ವೀಕ್ ಆಗುತ್ತೆ. ಕ್ಲೀವೇಜ್ ಆಫ್ ದ ಬಾಂಡ್ ಬಿಕಮ್ಸ್ ಈಸಿಯರ್. ಸೊ ಯಾವಾಗ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಆಗ ಆ ಬಾಂಡೆಡ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಕಡೆಗೆ ವಿಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಆಲ್ರೆಡಿ ಹ್ಯಾವಿಂಗ್ more electron density. Then this OH bond becomes what? Strong. When the OH bond becomes strong, then the cleavage of the bond becomes difficult. A bond cleavage agadu difficult agutte. Aga proton releasing tendency decreases. When the proton releasing tendency decreases, then the acidic strength also decreases. Then what is the conclusion? Acidic strength of carboxylic acid depends on are directly proportional to negative inductive effect, that is the presence of electron withdrawing group increases the acidic strength, whereas it is inversely proportional to positive inductive effect, the presence of electron releasing group decreases the acidic strength of carboxylic acid. So any group if it exerts negative inductive effect or it is electron withdrawing group, then it decreases the strength of the OH bond and thereby the cleavage of the bond becomes easier and tendency to release the proton increases, acidic strength also increases. Whereas any group if it is electron releasing, if it exerts a positive inductive effect, if it is attached to the carboxylic acid functional group, it increases the strength of the OH bond. When the strength of the OH bond increases, the cleavage of the bond becomes difficult, proton releasing tendency decreases and acidic strength also decreases. So this is the one more important applications of the inductive effect. Let me give the examples here. So you have to remember the acidic strength of carboxylic acid depends on tendency to release the proton, means it depends on the strength of the OH group of OH bond of COOH group. ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ? ಸ್ಟ್ರೆಂತ್ ಆಫ್ OH ಬಾಂಡ್ ಆಫ್ ದ COOH group. ಇದು ವೀಕ್ ಆದರೆ ಪ್ರೋಟಾನ್ ರಿಲೀಸ್ ಈಸಿ ಆಗುತ್ತೆ, ವೆರಾಸ್ ಇದು ಸ್ಟ್ರಾಂಗ್ ಆದರೆ ಪ್ರೋಟಾನ್ ರಿಲೀಸ್ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ. ಯಾವುದು ಪ್ರೋಟಾನ್ನ ಡೊನೇಟ್ ಮಾಡುತ್ತೋ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಆಸಿಡ್. ಯಾವುದು ಬೇಗ ಪ್ರೋಟಾನ್ನ ಡೊನೇಟ್ ಮಾಡುತ್ತೋ ದಟ್ ಈಸ್ ಮೋರ್ ಅಸಿಡಿಕ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದೀಸ್ 3 ಪಾಯಿಂಟ್ಸ್. directly proportional to tendency to release proton, directly proportional to group with minus psi effect, but inversely proportional to positive inductive effect. Clear? Now let us move on to the examples here. So the first one, acidic strength of carboxylic acid depends on negative inductive effect. So acidic strength directly proportional to inductive effect, negative inductive effect. If a group is electron withdrawing, if it exerts negative inductive effect, then it increases the acidic strength. But it depends on three factors. What are those? It depends on three factors. First one is the magnitude of group with the nature of group with negative inductive effect. Nature of the group with negative inductive effect. So what do you mean by nature of the group with negative inductive effect? Because the group, if it exerts negative inductive effect, what is the magnitude of the group which exerts minus psi effect? What is the magnitude of minus psi effect given by that group? Depending on that, the acidic strength mainly depends on nature of the group with minus psi effect. Means if a group exerts more minus psi effect, more is the acidic strength. If the magnitude is less, then acidic strength decreases. So that gives the nature of the group with minus I effect. And the second one, it depends on number of group with minus I effect. If a given carboxylic acid containing only one group with minus I effect, then the acidic strength increases. If the same acid containing more than one group with minus I effect, then the magnitude of minus I effect goes on increases, then the acidic strength also increases. As the number of group with minus I effect increases, acidic strength also increases. Now, what about third one? Third one is position of group with minus I effect. Position of group with minus I effect. Where the group with minus I effect is present, whether it is near to the source of COOH group or if it is very near to the COOH group, then its effect is more, then the acidic strength increases. If it is away from the COOH group, then the minus I effect, magnitude of minus I effect is less, and thereby acidic strength decreases. So therefore it depends on the position of group with minus I effect. So let us consider example one by one here. So first one is the group with, nature of the group with minus I effect, and consider NO2 CH2 COOH, that is C double bond OH, and one more I can give here F CH2 C double bond OH. So this is, as you know that, what is the name? What is the name of this acid? Acetic acid, correct? This is acetic acid. This is substituted acetic acid because one of the hydrogen atoms of methyl group in acetic acid is replaced by NO2 group. Then what is the name of this compound? Nitroacetic acid. Nitroacetic acid, correct? And what about this? Fluoroacetic acid. Fluoroacetic acid, correct? Fluoroacetic acid. Now what is the NO2 group? It exerts minus I effect. CH2 group exerts positive inductive effect, but the overall effect is again minus I effect here. The means the negative inductive effect given by the NO2 is predominates over the positive inductive effect given by the CH2 group here. So therefore minus I effect is more here, negative inductive effect is given by NO2, and here fluorine also exerts a negative inductive effect and it predominates over the positive inductive effect given by the CH2. Therefore the acidic strength depends on minus I effect here, and as we know that the negative inductive effect given by NO2 is more compared to that of fluorine. I have given the decreasing order of the group with minus I effect, correct? I have given decreasing order, the magnitude of decreasing order of minus I effect of different groups, in which NO2 group exerts more negative inductive effect compared to that of fluorine. Therefore, which is more acidic? Nitroacetic acid is more acidic than fluoroacetic acid. What is the reason? The reason is very simple. Magnitude of minus I effect given by NO2 is more compared to that of fluorine. So therefore, it depends on nature of the group with minus I effect. As the magnitude of minus I effect increases, the group with minus I effect is more, then the acidic strength is also more. If a group exerts more magnitude of minus I effect, then the acidic strength also increases. Second one, number of group with minus I effect. So consider the acetic acid when all the three hydrogen atoms of acetic acid is replaced by chlorine, that is trichloroacetic acid. So you know that what is acetic acid here? CH3COOH, correct? 3 hydrogen atoms are there. So replace all the 3 hydrogen atoms by chlorine, then what you get? You will get a trichloroacetic acid. What is the name of this compound? Trichloroacetic acid. So trichloroacetic acid, and now you take here CH2 Cl CH2 COOH. Here monochloroacetic acid or chloroacetic acid. Monochloroacetic acid or chloroacetic acid, you can say. Here the 3 chlorine atoms are there. All these 3 exerts minus I effect, negative inductive effect, negative inductive effect. Here only 1 chlorine atom exerts minus I effect. Therefore here magnitude of minus I effect is more. When the magnitude of minus I effect is more, definitely it is more acidic than chloroacetic acid. Again, depends on number of group with minus I effect. As the number of group with minus I effect increases, magnitude of negative inductive effect increases, acidic strength also increases. Now last one, position of group with minus I effect. Position of group with minus I effect. I will give the example here. Last one, position of group with minus I effect. See here, CH3, CH2, CH2, COOH. What is this compound? 1, 2, 3, 4. Butanoic acid. Correct? Now, you replace one of the hydrogen here by chlorine. It exerts negative inductive effect here because it is electron withdrawing. Correct? Now, so then group with minus I effect and the COOH group are very close to each other, whereas if you consider CH2Cl, CH2, CH2, C double bond O, OH. Now the position of Cl is away from COOH group because it's a minus I effect, negative inductive effect. So the influence of negative inductive effect of chlorine is less on COOH, but here it is more. Negative inductive effect exit ಮಾಡುತ್ತೆ chlorine, ಅದರ influence ಇಲ್ಲಿ ಜಾಸ್ತಿ ಯಾಕಂದ್ರೆ distance ಕಮ್ಮಿ. But ಇಲ್ಲಿ minus I effect exerted by the chlorine and its influence over COOH group is less because the distance increases. As the distance between the group with minus I effect and the COOH group increases, magnitude of minus I effect decreases, acidic strength also decreases. Distance ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗ magnitude decreases. ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅಲ್ಲಿಗೆ ಅಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಐ ಆಲ್ರೆಡಿ ಗಿವನ್ ಇನ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ಯೂಚರ್ಸ್ ಆಫ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಆಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಸೋರ್ಸ್ ಆಫ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಅಂಡ್ ದ ಕಾರ್ಬನ್ ಚೈನ್, ಇಫ್ ಇಟ್ goes on increases, magnitude of inductive effect increases. ಇಲ್ಲೂ ಕೂಡ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಅಲ್ಲಿಗೆ ಅದರ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಆಫ್ ಮೈನಸ್ ಐ ಎಫೆಕ್ಟ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. therefore the acidic strength decreases. therefore this acetic acid is more acidic compared to that of that. what is the name? This is 1 2 3 4. this is 2-chloro-butanoic acid. 2-chloro-butanoic acid is more acidic than 1 2 3 4. 4-chloro-butanoic acid. 4-chloro-butanoic acid. Clear? So 2-chloro-butanoic acid is more acidic than 4-chloro-butanoic acid because in 2-chloro-butanoic acid magnitude of inductive effect is more, whereas in 4-chloro-butanoic acid magnitude of inductive effect is less because of increase in the distance. Okay, now take down a question. Give the decreasing order of acidic strength of the following carboxylic acid. You have to give the decreasing order of the acidic strength. Okay, now take down few examples. This is not there in your text, you have to take the notes, you have to write down all these examples. Okay, so write down the question. Give the decreasing order of acidic strength of the following carboxylic acids. First one, here A, that is Cl CH2COOH, B NO2 CH2COOH, C Cn CH2COOH, D F CH2COOH, E I CH2COOH, and F Br CH2COOH. So the substituent group with minus I effect is attached to the acetic acid. Here one of the hydrogen atoms of acetic acid is replaced by the group with minus I effect. So you have to identify the group with the minus I effect and the plus I effect. It exerts minus I effect. This also 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 exerts minus I effect. And this also exerts minus I effect. But all the groups attached to this exerts minus I effect. Then we need to consider what is the magnitude of minus I effect. I have given in a decreasing order already. As we know that NO2 exerts more minus I effect. Then comes cyano group, nitroacetic acid, cyanoacetic acid. Next comes fluoroacetic acid, then chloro, bromo, then iodine. So what is the magnitude of minus I effect given by the groups? NO2, then comes Cl, then comes fluorine, then chlorine, then bromine, then iodine. So this is the order of magnitude of the group with minus I effect. So as the minus I effect decreases, definitely acidic strength also decreases. Now you give the decreasing order, which is more acidic, B, then comes C, then comes D, then comes A, then comes F, and then comes E. So this is the decreasing order. From here to here, acidic strength decreases. Acidic strength decreases. Now take on the second example. So A Cl2 CH2 COOH, B CCl3 COOH, D, Cl, CH2, COOH. So look at the groups attached here. 2 Cl2 groups are attached. It exerts minus I effect. 3 Cl3 groups are attached. It exerts negative inductive effect, but it is more because 3 electron withdrawing groups are there. Here only methyl group is there. It exerts positive inductive effect, and this exerts minus I effect. Chlorine. So here one chlorine atom, lesser minus I effect. Here 2 chlorine atoms, more minus I effect. Here 3 chlorine atom, further the negative inductive effect is more, but this exerts positive inductive effect. As we know that minus I effect is directly proportional, group with plus I effect is inversely proportional. The presence of methyl group decreases the acidic strength because it exerts positive inductive effect. Now, what is the order? What is the order now? Which is more acidic? B is more acidic. Then comes A, then comes D, then comes B. From here to here, acidic strength decreases. Why it decreases? Magnitude of minus I effect decreases, but B gives a positive inductive effect. Okay, now move on to the next example. So third one, CH3, CHCl, CH2COOH, A, B, CH3, CH2, COOH, C, CH2Cl, CH2COOH, and D, CH3, CH2, CHCl, COOH. Look at here, butanoic acid. This is 1, 2, 3, 4 butanoic acid, and this is 3-chlorobutanoic acid, and this is 4-chlorobutanoic acid, and this is 2-chlorobutanoic acid. And as you know that this compound does not contain any group with minus I effect, but this is the propyl group. It exerts positive inductive effect. Correct? Here is a chlorine. It exerts negative inductive effect, and here is a chlorine. It also exerts negative inductive effect, and here it exerts negative inductive effect. But magnitude of negative inductive effect given by this chlorine is more because the distance is less. Distance between chlorine and the COOH group is less. Correct? But here the distance increases, therefore magnitude of minus I effect is less. But here also the distance is increases compared to here, therefore magnitude of minus I effect is less here. Here still less, and here it is more. So therefore, and here there is no group with minus I effect. Then what is the order? The order is D is more acidic than A, which is more acidic than C, which is more acidic than D. You have to remember, from here to here, distance increases, minus I effect decreases. So in D and in C and in A, so from DAC, the distance increases, therefore magnitude of negative inductive effect decreases, and thereby acidic strength decreases. Now move on to the last example here, fourth one, CH3, A, CH2, COOH, B, HCOOH, then C, it is CH3, CH2, CH2 2COOH and D CH3COOH and E C6H5COOH. Now you try to recall the ethyl group exerts positive inductive effect, hydrogen exerts zero inductive effect, propyl group number of carbon is more, size of the alkyl group is more, so therefore it exerts very high positive inductive effect compared to here. Methyl group also exerts positive inductive effect, whereas phenyl group is electron withdrawing, it exerts negative inductive effect. So if this is the case, what is the order? So hydrogen exerts zero inductive effect, means phenyl group is electron withdrawing, it increases the acidic strength, whereas hydrogen not decreases, not increases, but it is more acidic than acetic acid. In the alkyl group, methyl, ethyl, propyl, magnitude of plus I effect goes on increases from methyl to propyl. Therefore, higher the positive inductive effect, lesser is the acidic strength. Then what is the order? Order is E is more acidic than B, which is more acidic than D, which is more acidic than A, this is more acidic than C. So this is the order of acidic strength of different acids. Okay, so you have to remember these 4 examples which are in a decreasing order, and these are very important. Okay, and this is important for your competitive exams. Okay, now let us move on to the last one, sixth one. Sixth one, basic strength of amines. Basic strength of amines. What are amines? Derivatives of ammonia. Ammonia, you know that NH3. What do you mean by derivatives of ammonia? When one of the hydrogen atoms of this ammonia is replaced by a group, any group, that is alkyl group, you can say R group, then it becomes NH2. So remember, ammonia and amines are bases. Ammonia is this, amine is this. Derivative of ammonia where one of the hydrogen atom is replaced by a alkyl group, So then this is called derivatives of ammonia, and it is nothing but amine. So this is amine. This is ammonia. Okay, and ammonia and amines are bases. Why they are bases? Because there is a lone pair of electrons on the nitrogen. There is a lone pair of electrons on nitrogen. Because of these lone pairs, these lone pairs are available for protonation. Available for protonation means by giving this lone pair of electron, they can receive the proton. So it receives the proton. So these lone pair of electrons are available for protonation. NH4+, it forms an ammonium ion. So during the formation of ammonium ion, both the electrons is given by the nitrogen that you studied in your covalent bond, chemical bonding, that is coordinate bond. It forms a coordinate bond with proton, and thereby it forms ammonium ion. So these lone pair of electrons present on a nitrogen is available for protonation. This phenomenon is called protonation. As you know that what is a base? Proton acceptor. So ammonia is accepting a proton, therefore it is a base. Here also there is a lone pair of electron on the nitrogen, it also accepts a proton, therefore it is also a base. Proton acceptor is nothing but a base. So the basic strength of ammonia and its derivatives depends on which factor? The factor which influences the basic strength of ammonia and amines is nothing but availability of these electrons for protonation. ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಈಸಿಯಾಗಿ ಪ್ರೋಟೋನೇಷನ್ಗೆ ಅವೈಲಬಲ್ ಆಯಿತು ಅಂದರೆ ಬೇಸಿಕ್ ಸ್ಟ್ರೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅದೇ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಪ್ರೋಟೋನೇಷನ್ಗೆ ಅವೈಲಬಲ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಆಗ ಬೇಸಿಕ್ ಸ್ಟ್ರೆಂತ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಆನ್ ದ ನೈಟ್ರೋಜನ್. ನೈಟ್ರೋಜನ್ ಮೇಲಿನ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಡೆಫಿನೆಟ್ ಆಗಿ ಇಟ್ ಈಸ್ ಅವೈಲಬಲ್ ಫಾರ್ ಪ್ರೋಟೋನೇಷನ್. ಈ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫ್ರೀ ಇತ್ತು ಅಂದ್ರೆ ದೇ ಆರ್ ಅವೈಲಬಲ್ ಫಾರ್ ಪ್ರೋಟೋನೇಷನ್. ಬಟ್ ಇಟ್ ಈಸ್ density, electron density on the nitrogen, if it is less, then availability of these electron for protonation decreases, basic strength also decreases. So basic strength of amines depends on availability of lone pair of electrons present on the nitrogen for protonation. ಎಷ್ಟು ಬೇಗ ಪ್ರೋಟಾನ್ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ ಆ ಬೇಸಿಕ್ ಸ್ಟ್ರೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಪ್ರೋಟಾನ್ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನ್ ದ ನೈಟ್ರೋಜನ್ ಏನಾಗಿರ್ಬೇಕು, ಪ್ರೋಟೋನೇಷನ್ಗೆ ಅವೈಲಬಲ್ ಆಗಿರಬೇಕು. it should easily take the proton or it easily undergo protonation. When it easily undergoes protonation, basic strength increases. ಸೊ ಆ ಪ್ರೋಟೋನೇಷನ್ ಡಿಫಿಕಲ್ಟ್ ಆಯಿತು ಅಂದರೆ ಬೇಸಿಕ್ ಸ್ಟ್ರೆಂತ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಆಲ್ ದೀಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ವಿಚ್ ಫ್ಯಾಕ್ಟರ್, ಅವೈಲಬಿಲಿಟಿ ಆಫ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಕನ್ಸಿಡರ್ ದಿಸ್ ಇಸ್ ಅಮೋನಿಯಾ. Here is a lone pair of electron. So let us consider any group is attached to this nitrogen. If this group is electron withdrawing group anta helkonಡ್ರೆ it withdraws the electron. When it withdraws this electron density on the nitrogen decreases. When the electron density on the nitrogen decreases, definitely ಏನಾಗುತ್ತಲ್ಲಿ, when the electron density on the nitrogen decreases, availability of these electrons for protonation decreases. ಪ್ರೋಟಾನ್ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋ ಟೆಂಡೆನ್ಸಿ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಈ ಗ್ರೂಪ್ ಏನ್ ಮಾಡ್ತಾ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ ನ ವಿಡ್ರಾ ಮಾಡ್ಕೊಳ್ತಾ ಇದೆ. ಸೊ ಇಫ್ ದ ಗ್ರೂಪ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್, ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಎಕ್ಸರ್ಟ್ಸ್ negative inductive effect. When the group with minus I effect is attached to the nitrogen of ammonia or amines, then the availability of electrons for protonation or proton accepting tendency of ammonia and amines decreases. Basic strength also decreases. Whereas if a group is electron releasing group, then it exerts positive inductive effect. When it releases the electron towards the nitrogen, then availability of these electrons for protonation increases. And ಈ electrons ಈಸಿಯಾಗಿ ಪ್ರೋಟಾನ್ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. When a group is electron releasing group, it increases the electron density on the nitrogen. Therefore, availability of these electrons for protonation or proton accepting tendency of ammonia and amines increases. When the proton accepting tendency increases, basic strength also increases. Then what is the conclusion here? Basic strength of ammonia and amines is directly proportional to positive inductive effect, whereas inversely proportional to negative inductive effect. So for that, let me give an example here. Consider the example CH3 group. If it is attached to one of the hydrogen atoms of ammonia, if it is replaced by methyl group, then it becomes methyl amine. Correct? What is the nature of methyl group? You know that it is electron releasing and it exerts positive inductive effect. Since it exerts positive inductive effect, availability of these electrons for protonation increases, basic strength increases. So compared to ammonia, methyl amine is more basic. So availability of these electrons, the proton accepting tendency increases, basic strength also increases. Instead of methyl group, if phenyl group is attached to the nitrogen, one of the hydrogen atoms of ammonia, if it is replaced by phenyl group, then this becomes aniline. Correct? This becomes aniline. this becomes aniline. Now phenyl group, you know that electron withdrawing group and it exerts minus I effect, negative inductive effect decreases the basic strength. Then you can say methylamine is more basic than aniline. Methylamine is more basic than aniline. The reason is that in aniline proton accepting tendency decreases. Why it decreases? Due to the negative inductive effect. Availability of these electrons for protonation decreases. But here availability of electrons for protonation increases. Now what is the order of basic strength? In the decreasing order, methylamine is more basic, then comes ammonia, then comes aniline. So here, from here to here, basic strength decreases. Basic strength decreases. Which is more basic? Methylamine is more basic. Then comes ammonia and then comes aniline. Okay, so this is the basic strength, decreasing order of the basic strength. You have to know about the nature of the group which is attached to the source of inductive effect where it is required. On the basis of that, you have to give the acidic strength of carboxylic acids and basic strength of amines. So in order to study these properties, the inductive effect is very useful. It tells about the basic strength of amines, acidic strength of carboxylic acids, stability of carbocation, carbon ion and carbon free radical. All these can be given on the basis of inductive effect. So inductive effect definition is important. Types of inductive effect is important, and what are the important features of inductive effect is important for your theory part, and for competitive part the applications of inductive effect is very important. You have to remember order of stability of different carbocations and the carbon ions. So these are very important for organic reaction mechanisms. Okay, so this is about the applications of inductive effect. In the next class, let us consider what do you mean by resonance effect and the mesomeric effect. Before going to that, let us consider what do you mean by resonance. Okay, so let us continue with that topic in the next class.